Expectations are that the Turkish economy will continue to grow at good pace and rate. But in order to sustain the growth of its economy, Turkey needs energy. Russia, Turkey's neighbor across the Black Sea, has enormous reserves of gas, which it needs to export to sustain and develop its economy. So, there exists a great potential for a strategic partnership between Russia and Turkey. The Blue Stream project was a natural extension of this spirit of partnership and the appropriate means to serving the interests of both countries. The Blue Stream project arose out of a joint venture between Italy's Eni and Russia's Gazprom. Its objective: to supply 16 billion cubic meters of Russian gas annually to Turkey. To achieve this objective, BSPC, an Eni-Gazprom joint company, contracted Saipem to design, procure, install and commission two 380-kilometer-long, 24-inch diameter, 31.8-millimeter wall thickness pipelines across the Black Sea in water depths of 2,200 meters. Saipem headquarters, Milan, Italy. These two engineers will have to face all the technical challenges of such a demanding project. The S7000 has already been upgraded with the J-Lay tower, and the system performed very well during the Norway trials. The design of the pipelines had to take into consideration H2S concentration in water depths greater than 200 meters.
The pipeline characteristics has been strictly defined within selected ranges of mechanical properties and corrosion resistance.
For this type of Black Sea environment, what type of corrosion coating and cathodic protection has been selected?
It's been selected a 4-millimeter 3-layer polypropylene coating, and for the anode has been preferred a zinc anodes.
The Russian slopes have unique geotechnical characteristics, and because they provided very narrow channels through which the pipelines were to be laid, an extensive survey was performed to determine optimum routing.
We have studied 5 or 6 canyons, and we have selected 2 for the pipelining. One is on the west route for the first pipeline to be laid, and the other one is on the east side for the second one. And we have verified that this canyon, this pipeline route, are suitable for a safe laying. So we can confirm that we will lay safely these 2 pipelines, and the behavior of the pipe on the seabed will be safe, and with very few intervention after laying, the 2 pipes will be safe.
35 hectares of land was allocated for the Blue Stream project in Beregovaya, near the town of Jupka, for the construction of a compressor station with a capacity of 16 billion cubic meters of gas per year at a pressure of 250 bar. The gas requirements for the project will be met by linking gas fields near Stavropol to Beregovaya via approximately 380 kilometers of land pipelines. During excavation works at Beregovaya, an ancient archaeological site dating from the 1st century AD was discovered. Great care was taken not to disturb such an important find. The work on the shore approach area is well on its way, and everything is ready for the Castoro 8's arrival. In 1919, Kemal Atatürk, the founder of modern Turkey, landed on the shores of Samsun to lead the revolution that would free Turkey from the Ottoman Empire. Turkey became a secular country, and took the first steps down the path toward modernization and economic growth. Just as Ataturk led Turkey forward in its economic growth, so gas arriving from Russia at Samsun will fuel the further impetus to develop the Turkish economy by providing a stable energy source. Roughly 5 hectares of land has been allocated for the project at Samsun. Saipem rented a 170,000 square metre area of the port at Samsun as an offloading point for the Blue Stream project's pipes, equipment and machinery, stacking the single joints and transporting them to the fabrication yard where quadruple joints were produced. At the fabrication yard, single joint pipes are picked up from the stack and loaded on the transfer belt. From the transfer belt, the pipes are aligned before welding. Root and hot passes are applied with the Paso welding system. The remaining passes are performed with submerged arc welding. First, 2 double joints are produced in different buildings, then they are lined up and welded to obtain the required quadruple joint. After welding, an NDT is performed with automatic ultrasonic equipment. The weld quality is then checked online. After the weld has passed inspection, the welded joint is then moved to the field joint coating plant. Here, the welded joint is prepared for field joint coating, and a polypropylene field joint coating is then applied using automatic equipment. Finally, the quad joint is transferred onto a stacking yard. At peak production, 100 quad joints were produced each day, providing sufficient supply to feed demand on board the S7000. The quad joints were picked up from their stacking yard and transported to quayside using dollies. During the construction of the first leg of the Blue Stream pipeline, special containers were used, having a carrying capacity of 50 quad joints. To optimize loading operations based on lessons learnt during the laying of the first line, this sequence was modified for the second leg of Blue Stream with single quad joints loaded onto the pipe carriers. In October 2001, the shore approach excavation using the marine spread began. Onshore preparation work and installation of sheet piles in the surf zone were carried out a month before. Using a cutter suction dredger and a hopper suction dredger spread, a trench 10 meters wide was prepared from the shoreline to a distance of approximately 1.2 kilometers. The width was sufficient to lay 2 pipelines in a single trench, with a center-to-center pipe distance of 5 meters. The dredgers then discharged and stockpiled the spoil material to a distance of 150 meters from the trench, using a floating pipeline and spreader pontoon. The same material was then used to backfill the trench following pipe lay. In July 2001, Castoro 8 crossed the Bosphorus Straits. Before the crossing, extensive checks were made to ensure that the A-frame of Castoro 8's 2,200-ton crane had sufficient clearance between the bridges and cables that crossed the Bosphorus. Special tugs and firefighting crews were hired in order to prepare for any emergency. During the crossing, all other shipping traffic on the Bosphorus Straits was stopped. In June 2001, the S7000, having wrapped up a full North Sea construction season, began navigating its way towards the Black Sea. Its first stop would be Palermo, Sicily. Extensive studies and surveys were carried out in the Bosphorus Straits during 2000 to establish the current speed, water depth, and the clearance afforded between the bottom of the bridges and cables and water level on the shipping thoroughfare. Based on these studies, Saipem developed a system to lower the S7000's A-frames so that the vessel could pass under bridges and cables with no danger of collision. The S7000 docked in Palermo to lower its A-frames. This operation was carried out in 3 days. Then the S7000 lifted anchor and set out to cross the Bosphorus Straits. After all readiness checks were carried out under the watchful eye of certification body DNV, Castoro 8 started shore pull operations in September 2001 on the Russian side, marking the first of the pipes to be laid under the Black Sea for the Blue Stream project. Castoro 8 completed shore pull operations and continued to lay the pipelines 15 kilometers out from the shore in water depths down to 380 meters for subsequent pickup by the S7000. Castoro 8 is a traditional S-lay vessel. After the beveling phase, the pipes are aligned and welded. After welding, an ultrasonic NDT is performed. The field joint starts, and the joint is coated with polypropylene and the gap between the concrete coating filled with polyurethane resin. The pipe is then laid. A temporary air compressor station is installed and commissioned prior to J-lay laying for contingency purposes. In the first week of August 2001, the S7000 arrived on the Bosphorus to begin its historic crossing. The crossing was a spectacular endeavour, the first time in the history of the Bosphorus Straits that a vessel of this scale and size had attempted a crossing. It has taken Saipem nearly 2 years of preparation to ensure a successful operation. The S7000 was ballasted to around 27 metres, so that the 1 metres clearance was afforded between the top of the lowered A-frame and the bottom of the bridge. After the Bosphorus crossing, the S7000 was taken to a sheltered area while the J-Lay tower was being mounted. A Lupo linear winch was installed onshore in Turkey. A cable attached to the pulling head on board Castoro 8 was brought on shore and connected to Lupo. The Castoro 8 is positioned approximately 1.5 kilometers from the shoreline. After welding each joint, a pull is communicated to the Lupo operator. The winch was then activated and a 12-meter pull performed. This operation was repeated until the pulling head arrived on the beach. From there, the Castoro 8 continued laying operations, leaving the pipeline at the designated tie-in point in some 30 meters of water. The multi-purpose vessel Polar Prince carried out the cable crossing preparation works. 2 seabed cables, namely ITUR and BSFOCS, lying in water depths of over 1,000 meters, had to be prepared in advance of the S7000 crossing the area during pipe laying. When the S7000 reached location, continuous touchdown monitoring was performed to ensure that the pipe was placed within plus or minus 1 meter of its intended location. Pipes were uploaded from the pipe carrier using the S7000's cranes and stacked in a dedicated area on board the vessel. From the stacking area, using dedicated quad-joint handling cranes, the joints were loaded onto a pipe transfer area for beveling. The quad joints were inspected to confirm that their corrosion coating had not been damaged during transit from shore to the S7000. The joint ends are then beveled to provide the required configuration and angle of the edges for welding purposes. Each joint is then transferred onto a turning area to quarter turn the longitudinal seam so that no two adjoining quad joints will have the longitudinal seam at the same place. The quad joint is then transferred onto a pipe loader lifter and the pipe upended to be brought inside the J-lay tower. The quad joint is brought inside the J-lay tower using another set of clamps and aligned with the quad joint below. An internal line-up clamp is then placed inside the pipe while the welding leads are attached to the quad joint. The joint is then lowered to the welding station and aligned with another joint. Once aligned, welding commences. Sophisticated state-of-the-art technology developed specifically for the Bluestream project was used for welding. It took Saipem some 2 years to develop and fine-tune the welding technology to suit the demands of the project. The weld defect criteria adopted by DNV was close to zero tolerance. After the welding is completed, the weld is lowered to the NDT and field joint coating station. At this point, the automatic ultrasonic testing equipment is mounted and 100% weld inspection is carried out. The automatic ultrasonic testing equipment is a state-of-the-art inspection technology developed by Saipem in conjunction with the weldability trials carried out specifically for the Bluestream project. After the weld has passed inspection, a green light gives the signal that the weld has been accepted and field joint coating commences. The field joint coating equipment used on the project is also state-of-the-art technology developed by UPEC to Saipem's stringent specification. Saipem witnessed extensive trials of the equipment carried out in Germany during 2000 and 2001 before being used on the project. After the field joint is completed, a signal is given to the bridge that the quad joint is now ready for laying. At this point, the bridge activates the tensioners, which have a lay capacity of 525 tons and a contingency holding capacity of more than 1,000 tons, and the barge moves forward in a controlled manner to lay the 50-meter quad joint. Even the environmental inspectors approved the quality of Saipem's work. The S7000's dynamic positioning system has been augmented specifically for the laying of the Bluestream pipeline. The DP system allows the S7000 to maintain stable station keeping even in winds of approaching 30 knots. The Topaz system, Another of the special state-of-the-art technologies developed for the Blue Stream project by Saipem monitors the pipe from the vessel up to the touchdown point to ensure that the configuration is within specification. When the pipe is being laid, a Sonsub ROV is deployed from the S7000 to carry out continuous touchdown monitoring to make certain that the pipe is being laid on the seabed in keeping with preset tolerances. The S7000 completed laying of the pipelines after it reached laydown location in some 150 meters of water on the Turkish side, having traveled and laid roughly 360 kilometers from the Russian shore. To avoid free-span and post-lay pipeline stresses, Polar Prince, the multi-purpose DP vessel, deployed the Beluga trenching equipment. Beluga is a deep-water post-lay trenching machine designed for pipeline trenching up to a maximum slope angle of 40 degrees in water depths ranging from 10 to 2,200 meters. Once attached to the pipeline, the Beluga propels itself using 8 polyurethane-coated rollers capable of overcoming anodes and buckle arresters. Trenching is performed by 2 up-milling cutting discs, allowing trenching in soils varying from very soft clays to 30 megapascal clay stone. A trench depth of 1.5 meters can be achieved in a single pass, and a maximum trench depth of 5.1 meters is achievable by multiple passes. The Castoro 8 arrived at the laydown location, picked up the line and continued to lay the pipeline to the intended tie-in location adjacent to the previously laid pipeline. With the aid of divers and 6 davits on the side of Castoro 8, the 2 sections of the pipeline were lifted, appropriate measurements taken, and then cut. With both pipelines held on the side of the vessel, above-water tie-in requires a long good weather window to avoid risk of pipe damage. The pipeline ends are beveled, and then with an external line-up clamp, the pipes are aligned and manually welded. The weld is NDT tested and then field joint coated. Finally, the pipeline is laid down in a controlled manner. The completion of the tie-in was a historic moment for both Russia and Turkey. After the successful completion of tie-in operations, hydro testing of the pipelines was carried out. large fill